Hi guys, so this is going to be the last video for chapter 11. It is 11.4, where we're going to talk about the applications of factorial designs. So, we've talked about all this kind of in theory. I mean, we've talked about examples, obviously, but how exactly could you use this in your own research process? You, or this corresponds to learning objective number 7, which is the last learning objective of the chapter. Where we're going to describe the 3 applications of factorial design. And of course, there's others, but this is like the 3 main ones. The first one is adding a factor to an existing study. The second one is using a participant variable as a second factor to control the variance in a between subjects design. And then the third application is using the order of treatments as a second factor to evaluate order effects in a within subjects design. And then we're going to talk about the advantages of all of that as well. So let's get started with the first one. Okay, so this is talking about expanding and replicating a previous study. Um, so um, just to remind you, replication is repeating a study using the same factor or independent variable exactly as it was used in a previous study, right? You have to use it the exact same way. And that is considered replication. Expansion is when we're doing the replication part, but we're also adding a second factor to form new conditions or new participant characteristics, or whatever the case is, but we're adding a second factor to study. So we're not changing their original independent variable. That first factor is staying exactly the same. So we're replicating that part. We're just adding an additional variable or factor to further evaluate the relationship that exists there. This is going to be able to show us, the specific application is going to be able to show us whether the reported effects or the results that from the previous study can be generalized to different situations or different contexts or different conditions, or also to different populations. Because if that second factor is different conditions, then you're going to be able to see if you get the same relationship or the same results. If you use different participants, several different types of participants, then that's going to tell you about being able to apply those same results to new populations, right? So you would use so for both of these types here, for the new situations or the new populations, the format would be the same. You would take the original factor 1 or independent variable, that treatment, and you would do that same replication part, but you would do it under a variety of different conditions. And the different conditions would be your second factor or your second independent variable. Also, the other way to look at new populations would be, again, replicating that first factor, that first independent variable or treatment, and you would just do that with different types of participants. And so the different types of participants would become your second factor or your second independent variable. The example that they used in your book was that aggression study, the video game violence. They wanted to study that if video game violence led to more aggressive behavior. And so other studies had previously been established showing that violent media, being exposed to more violent media, whether that's TV or movies or video games or whatever, would lead to possibly more aggressive behavior. But the researchers that did this particular study wanted to know if they could replicate that, which is the first factor, the violent versus non-violent game. But they wanted to particularly see if they could replicate that for both females and males. They wanted to know if there was a difference there or if it was the same or whatever. And so gender became the new factor, right? And so you can see in this example here, or this figure 11.9, that it now looks like that 2x2 matrix that we are so used to seeing here with Factorial Designs, with our two factors, right? So that is the first possible application. The second one is reducing the variance in a between subjects design. Now, you remember that in a between subjects design, part of the potential disadvantage or a potential confound or potential issue is the individual differences within the groups. So remember, if this is a between subjects design, in order to see if there's a treatment effect, in order to see if the independent variable is changing the dependent variable in some way or leading to a change in the dependent variable, we need to be able to determine a difference between the groups, right? That difference is what we are assuming is because of the independent variable. So you want a difference between the groups. You don't want a bunch of differences within the groups, because remember, that creates that static that it makes it hard to see the difference between the groups if there's so much differences within each of the groups. And so that variance within the groups needs to be reduced as much as possible in a between subjects design. So in order to, or one way to do that is using whatever participant variable you're worried about possibly causing that large variance within the groups. You can use that as a second factor, or a second, independent variable, or if it's a participant variable, it's a quasi-independent variable. And so you can use that to determine or to make it so that you can more easily detect the variance between the groups to see if there's an actual effect on the dependent variable from that first factor or first independent variable. So of course, as it says, it's greatly reducing the individual differences within each of the treatment groups, which is what we're going for. And it does not sacrifice external validity. So remember, a way you might be thinking, well, a way to reduce this variance, we talked about this, is holding a variable constant or restricting the range. And you can do that, of course, but remember that that limits the external validity, your ability to generalize to the population, the larger population of the sample that you're studying. Because if you're holding that variable constant, like looking at only 10-year-olds, or if you're limiting the range where you're only looking at 10 to 12-year-olds, then you aren't going to be able to apply the results you find to other age groups, right? And so possibly a better way to reduce that variance without sacrificing external validity would be to add age as a second factor. And so you can see they did that here in figure 11.10. So they had two different treatments that they were comparing. And there was a group, it was 12 participants ranging from 6 to 14 in both groups, right? So it's a between subjects design, treatment 1, treatment 2, right? But it said in your chapter, they were worried that age was going to be a factor, that because the 14-year-olds are so much more mature than 6-year-olds, and there's just a lot of life and things that happen between 6 and 14, that could be affecting their results. It could be affecting the treatment that is happening, to the dependent variable. So they decided to use age as a second factor, which is this part B, this second matrix down here, which really this is the only really true matrix here, but it's a 2x3, you see. And so what they did was they still had the two treatments as one factor, that's the columns. And then in the rows, we have a second factor of age now, where they have a younger age group, which is 6 to 8-year-olds, a middle age group, which is 9 to 11-year-olds, and an older age group, which is 12 to 14-year-olds. And so now they can compare those age groups to see if there actually is an effect of age on the dependent variable, but also to see if there's an interaction here between age and the treatments, to see if that really is affecting, if it's affecting the treatment, which is then in turn affecting your measurement, whatever your dependent variable is. So hopefully that helps kind of give you guys an example of that application. And so our third and final application is evaluating order effects within subjects design. So again, just like we talked about helping with variance in the between subjects design, because that's always a concern with between subjects. Hopefully you remember that the common problem with within subjects designs is the order effects. So same as we did with the between subjects, we're going to use the order of treatments, the thing we're worried about, that we're concerned about being a confound, we're going to use that as a second factor. That's going to become our second independent variable. And that would make it possible for us to evaluate these order effects that may exist in the data and possibly separate them out if we want to. So, you may have these treatments and you're wondering, well, where are these order effects occurring within these treatments, or how big are these treatment effects? For example, you may be asking the question in your research, is treatment 1 more effective if it occurs before or after treatment 2? Or if it occurs between treatment 2 and 3, or, any kind of combination of that, depending on what variables you're looking at. And so if you want to know that kind of information, you can add the order of treatments as a second factor to look at that. And so the example, let me pull it up in your book, is this figure 11.11, where they have the 2 treatments as the factor. Excuse me. And then the rows is our second factor here, and that's the order of treatments. So what we mean by that is the first group of participants would receive the treatment 1 first, and then the treatment 2. And group 2 would receive treatment 2 first, and then treatment 1. So we're switching the order of the treatments. And you can imagine if you had 3 treatments, it would be a little bit more complicated. You would have to do, group 1 would do 1, 2, 3. Group 2 would be 1, 3, 2. Group 4 would be 2, 1, 3. I mean, you see what I'm saying? There's lots of different combinations with the orders that you could do the 3 different treatments, but that would be how you would do that. And by comparing group 1 to group 2, as far as the order of treatments here, you would be able to see if there were order effects and where it occurs, and if it's affecting the dependent variable, and also if it's affecting the treatment, which is in turn affecting the dependent variable, again, if there was an interaction. So what that looks like, going back to our slide, it says there's 3 possible outcomes that can occur from this. And the first one is that there's no order effects, right? And so that would mean if we go to 11.12 here, this is showing you no order effects. So what that means is that there's no interaction between our 2 factors here, between the order of treatments and the treatments themselves. There's no interaction. Does it actually show? It doesn't actually show the line graph, but if they showed the line graph, it would not be, the lines would be parallel, right? They would not intersect. There's no interaction there, and you can see that because the means are if you track the means like we talked about in the matrices, or in the cells rather, I'm sorry, my brain is not working today. In the cells, you can see that it follows 20 to 30, 20 to 30. It follows, and then there's no difference between group 1 and group 2. So there's not even a main effect for the order of treatments because those means are the same. So literally there are no order effects at all here. Now, it is possible that you could have symmetrical order effects. That is the second possible outcome. And so this is showing an example of that here. And you can see that the means are slightly different. And you can see by the line graph here that there is an interaction. But if you look at the means in the rows for the order of treatments, they're the same again. 27.5, 27.5. They are higher than the first figure, but they are still the same, which means there's no main effect for order of treatments, but there is an interaction, which means the order of the treatments isn't affecting the dependent variable directly, but it is influencing the way that the treatments themselves are affecting the dependent variable. So there is an interaction there. And because the order effects are the same for both treatments, so here it caused a 5-point increase in group 1 when they went from treatment 1 to treatment 2. Treatment 2 ended up being 5 points higher than it originally was. And group 2, even though they had a different order, it still increased the second treatment that they got. So that means in treatment, so for them, that means that treatment 1 was 5 points higher than it originally was for them because treatment 1 was last for them. So because there are the order effect was the same for both groups, they kind of balance each other out, which is why it doesn't look like there's a main effect for order of treatments, but there is an interaction, of course, there, because obviously there were order effects here. So sometimes it's symmetrical, but a lot of times it's not symmetrical. So that's the third option for an outcome here, and that's non-symmetrical order effects. So here is visually what that looks like. Again, you can see that there is an interaction because the line graph crosses, but you'll notice that where they intersect is not at the midpoint. So in our other figure, they crossed at the midpoint. That's because they were equal effects. They were symmetrical, right? But if you look here, they are not crossing at their midpoints because it is not symmetrical, okay? So the order effects are not equal across both groups. And if you look at the means within the matrix there, you can see that the order effects are not the same. And if you look at the little diagram above that where it's telling you how much the order effect changed, either by 10 or by 5, that shows you as well what the order effects were. What I want you to notice here is that so in this case, for whatever reason, having treatment 1 first caused treatment 2 to have a 10-point increase. So let's say it was a practice effect. So for whatever reason, when you had treatment 1 first, when you experienced treatment 1 first, you were much better at treatment after treatment 2. But if you received treatment 2 first, it didn't have as much of an effect. It did have a little bit of a practice effect because your score increased by 5 on treatment 1 on your second measurement, but it didn't increase quite as much. And so because of that, that is non-symmetrical, right? And so if you look at the means, you see that we do actually have a main effect here for our order of treatments visible by the means because they are different. But we also, of course, had the interaction because of the line graph, but also just from the pattern of the cells there. And so let me take my notes and make sure that I'm not forgetting to tell you guys anything. So yeah, so since the effects are not equal, there are still order effects here. The order of the treatments is still affecting our dependent variable and our treatments. Specifically, it's making treatment 2 look more effective than it probably really is for group 1, and making treatment 1 look more effective than maybe it really is in group 2. And so again, this is a great way to determine these order effects so that you can separate them out from your data and determine how much your treatments are actually impacting your dependent variable. Okay, let me make sure. Yeah, okay. Oh, and I did want to remind you, I know we talked about this in the last video, but the part of the way you can tell if you don't have a line graph that there's an interaction, if you look at the cells within this matrix, you can see that it doesn't follow the pattern. If you look at treatment 2 and group 1, the mean is 40. And if you go down in the column there, then it goes in group 2, the mean is 30. Well, that follows with the overall means for order of treatments, because group 1 was higher with a mean of 30, an overall mean of 30, and group 2 had an overall mean of 27.5, so it went down. So it's going down. Group 1 was higher than group 2. That makes sense. But if you look at treatment 1 in that column, group 1 had a mean of 20 and group 2 had a mean of 25. So it increased in group 2. Well, those don't match, right? That didn't follow the pattern because that increased instead of decreased. So that means that okay, hold on, honey. Sorry, my daughter is needing something. And so that is what helps you determine that there is an interaction occurring without the line graph. Of course, the line graph is visually easier to see, but just so you remember, you can still see it that way too. Okay, so let's go to our learning check and look at number 1. Learning one. Question 1 says, how can variance be reduced in a between subjects design? And remember, we just talked about this, that for between subjects design, the variance that we're worried about is within the groups. And so we can add a participant variable like age as a second factor to reduce the effect of people to being different ages or whatever they are affecting the variance. And so the answer here is not this third answer. I know that your ebook is selecting counterbalance. That third answer is the correct answer, but it is not. So I just wanted you to be aware. I need to have a little alarm going off that this is incorrect. Your ebook is incorrect. It is actually the second answer here. The use a factorial design, adding a participant variable such as age as a second factor. The second answer here, that is the correct answer for this question. Some of you may have already figured that out, because if you go down to this next question, it's the same set of answers, and the answer is actually the third answer. So they just made the mistake of making that third answer the answer for both questions. But to go over why this is the answer for number 2, how can order effects be measured and evaluated? So this is referring to the within subjects design. We talked about, remember, order effects are the problem here. And so how do we measure and evaluate them? With a factorial design, we can counterbalance switching up the orders using that order of treatments as a second factor, like we just talked about in the last example. And that is how we can measure and evaluate those order effects with a factorial design. And then the last question is, which of the following is a possible use for factorial design? And our possible answers are replicate and expand previous research, which that was the first option we talked about. And then examine order effects for within subject study. That's what we talked about in the very last example. And then reduce variance in a between subject study. And that was the second thing we talked about today. So the answer is all of the above. That is literally the three applications there for factorial design that we discussed. So let's see, the self-assessment, because that is it, actually. That's it for 11.4, so that's it for Chapter 11. And so to review all of Chapter 11, how can a multi-factor design help examine a more real-life situation? Remember, it's those interactions of variables that we can now look at with two or more independent variables or two or more factors. We are able to see interactions, which is more an example of a real life situation, because variables don't typically act alone independent of all other variables in our lives, right? There are interactions most of the time. So how are main effects different than interactions? Remember, main effects mean you're just looking at the single independent variable and how it affects your dependent variable, like we talked about at the very beginning of this course or this textbook, just the one independent variable affecting the dependent variable, one at a time. We're just looking at the one-to-one relationship there. The interactions is when we're talking about one independent variable affecting the other independent variable, which then affects the dependent variable, right? So that is that it depends scenario, where you're saying this independent variable or this factor could affect our dependent variable, but it depends on this other variable, this second variable. So that's the interaction we're talking about, and that's how it's different than a main effect. How does the ability to mix designs within a single research study provide researchers with the potential to blend several different research strategies within one study? So this is just talking about what we talked about in the video before this, about how you can combine a between subjects factor and a within subjects factor, or a non-experimental or quasi-experimental factor with an experimental factor. And you can do that within the same study. So it doesn't have to be all or nothing, all one way or one the other. It can be, but you can also mix. And then last question is, what are the three specific applications of the factorial design? And that's literally what we just talked about in the last question of the learning check, where we can replicate and expand previous research. We can examine the order effects in a within subjects design and reduce the variance in a between subjects design within those groups. So that is a quick review of Chapter 11. And so now that Chapter 11 is over, we go back to those chapter objectives. There's 4 on this slide, and there's 3 on this slide. We talked about all 7 of those. And remember that you can screenshot this, but also you can, these are in your textbook as well. Remember, you can review your learning checks and your chapter summary. That always does a great job of kind of wrapping everything up, and the key terms and things like that, to help you guys make sure you have a grasp on all this material before we move on to the next chapter next week. So again, I'm here if you guys have any questions.